We're in design phase class, so very soon we're gonna revisit your domain model class diagram to convert it to what we call a first cut design class diagram. And there is only one object-oriented principle that we're gonna go by at this time, and that is, well, what do you think is the relationship between capsules and what we learn in class? Well, they have things in them, and there are different amounts of different things in there. Now, if you were to create a capsule at house, it would be very difficult because you have to measure things, you have to put them together, and it's not easy. So they did that for us. They put things that should be together. They covered them with a shell, and that shell protects them from unwanted change, temperature, moist, and it hides the details from us. Yes, we don't need to know exactly how many milligrams of this chemical or that substance is in the capsule. So they hide and they protect. That principle that we go by to create our first cut design class diagram is called encapsulation. So look for the data. Where is the data? If you need to work on that data, put the work as close as possible to that data. So meaning that if you have database and I need to calculate your age, the calculation should be in your class. So when we talk about capsules in object-oriented design, those are classes, very well-defined units that they do something for you. Details of calculations are in there, so they're hidden from other modules, other classes. They're also protected because if someone wants to work with any of the attributes of your class, they have to go through the methods that you have defined. They can't just take them and do anything they like. They need to go through the methods, and in the methods, you've given them specific ways to manipulate data in your classes. So encapsulation, data and procedures together. Let's look at some examples. Before we do that, just a quick review of what we did in analysis phase. This is our domain model class diagram, a use case diagram, an activity diagram, system sequence diagram. Some of you have done that. State machine, we didn't do those. Here in design phase, we're going to focus on two very important diagrams. One of them is sequence diagram, has more details than what you had in your system sequence diagram, and we have our class diagram. It will have methods, it will have navigation visibility, and we're going to talk about some object-oriented principles next week that will help you make them better in terms of design. Now, sequence diagram, it shows the steps. It does almost the same thing as you do in your activity diagram, but it's going to have a lot of details, and this is probably one of the hardest visual models that we create in this class, just because it has so many different small pieces that go in it. Now, the difference between a sequence diagram and a system sequence diagram is that system sequence diagram, you see the system as a black box. Here, not anymore. The system is not a black box. The work is done by a series of classes or objects of those classes, and you're going to tell your coders what objects are going to play a role in delivering a specific feature. So this is the notation for a design class diagram. You have your name, you had before attributes and methods. This is just another section on your diagram. This is an example. You have your math class. This is what we call a stereotype. Explains what kind of class is this? So it's a higher level information. This is a utility class. Everybody can use them if they need mathematical function. 2 attributes that are public, 1 that's private, and a number of mathematical functions that anybody can use if they need to. So the stereotype was utility. You can see the list of stereotypes on another slide. You can choose to define them in your design class diagram, but I don't require that. This is an ellipse in a geometrical application, and these are some of the behaviors it has. So you have the data. If you wanted to calculate circumference and area, this is the place to put the calculation. So encapsulation applies here. I have the data here. Calculations should be here, not anywhere else. And a number of getters and setters that you've seen in your Java programming classes. A book in a library or a book copy. There are 2 different things that you usually put in your library application. So this is a book as a title, and you know the number of copies on the shelf. So this book knows that, and it can be borrowed. If you want to borrow it, there is a parameter, and that parameter shows which copy you're borrowing. And the parameter could be defined by an external user or could be defined by another object within the system. So we don't worry too much about parameters and where they come from, but the design says that we need this parameter. Some of your favorite games, Tetris, Pac-Man, and Asteroids, and some of the behaviors. Make sure you think about the behaviors. Pause right now and then come back in a few minutes. Okay, you are back. These are some of the behaviors of blocks here in Tetris: falling, moving, rotating. Some of the behaviors here, and some of the behaviors here. These are going to be your methods. Going by encapsulation and encapsulation only. If you look at my classes and these behaviors, where should they go? Pause the video and come back. Okay, you're back. These are the behaviors. Shopping cart knows the total. Email should be sent by the email class. Information about the order are in the order. So any process is working on information that's in the order should be in the order. Same for others. So encapsulation only. Put the procedure close to the data. What is very important here as an additional item on your first cut design class diagram is navigation visibility. Who can talk to whom? Who interacts with whom? And we're talking about objects here. So I have an example here. A customer can invoke methods of sale or can have sale object as its attributes or parameters of its methods or return type of its methods. Any of those gives one object navigation visibility to another object. Basically, what we're saying is that these objects interact, and this is the direction. One has access to information in the other. One has objects of other as attributes, parameters, or return types. Any of those. The discussion can get very technical here, but we're going to avoid that and keep it very simple. So that we call navigation visibility. Sometimes it goes one way, sometimes it goes bidirectional, and sometimes it doesn't exist between 2 classes. Your association links should help you identify this navigation visibility links, but you should go a little bit beyond that. you may have to find navigation visibility links that you didn't think you need in the past. So here is another example from course schedule to course that goes into this direction. Some of the guidelines here, navigation visibility links, they go from more independent classes to less independent classes. So if you have a one-to-many association, it goes from one side to many sides. If you need an information from another object, that is a navigation visibility right there. Keep in mind they could be bi-directional, and if you have mandatory or optional association, it goes from the side that is optional to the side that is mandatory. This is an area that requires some work, some back and forth. So do not feel frustrated if you think you're not able to set the navigation visibilities and their directions. Come up with something, a draft, and send it to me. In your lab 6, we need navigation visibility links and we need methods. And the only principle you're going to apply is encapsulation.